well, what do we got here? This is a crazy contraption you got going.
I've done a little bit of work off camera. So a couple months ago, we went and visited Snowmax Performance, Grant and Erica, and they let us rip some watercross sleds. And we immediately got addicted to it. I came home and started working on this thing because it's basically kind of beat and not good for much else.
This was like one of the bonus sleds from last year's challenge. You know, when we got really fired up about old snowmobiles and just started buying ones we didn't need, this was one of those. And it was just sitting around really without a purpose. It now has a purpose.
Mm-hmm. Yeah, so I started out, this was just a 121 short track. I put rail extensions on it. And then to get it to sit the way it sits, I took the center shock out and actually put one of the front springs on it, which was a little bit longer, cranked the preload up, so now it's got this crazy stance that's only good for watercross, basically. I happen to have a 144 track off of my Apex, which is a ripsaw. It's 1.25 inches. I think the lug height is good, because apparently you don't want big paddles for watercross. It slows the track down.
That's strange to me.
Yeah, it's counterintuitive. I think it'll be okay. It's definitely not great, but it was free basically. So I came up front, started stripping her down. Basically just wanted it to be as light and simple as possible. So I took the headlight, the gauge, cluster, all that off. Removed the gas tank and oil tank. I got this little gas tank in here. The small gas tank allows you to only run like a few gallons of fuel and not have it slosh around in the big stock tank. It's pre-mixed now because for when it inevitably sinks, you want it as easy as possible to clean out and get it out. I mean, it's gonna sink. We're gonna sink it a lot.
Gonna sink.
That makes sense.
Definitely.
Put some big giant handlebar risers on this thing that didn't really fit, but I ground them up. These are handlebars off of a newer Apex. Got a finger throttle on there.
Ooh, I like that.
Just for fun. They seem kind of cool, and I've always wanted to try one. New kill switches and stuff I haven't wired up yet. Got an exhaust, just a really crappily made exhaust, the cheapest muffler I could find. And this is important because apparently in the stock location where the exhaust dumps out the bottom, you can actually just basically fill the muffler with water and install the machine in the middle of a run. Yeah, so this is just piped straight up and out. It rings your ears real bad.
Obscenely loud, which is good.
Then this is basically just for fun, but I took an old set of Apex skis and hacked them down and moved the mounting location to make a set of mini skis because I didn't want to buy mini skis.
Wow.
This is a budget build if you haven't picked that up. Let's see. Oh yeah, then I moved out to the back. I think this is what I'm working on now. Made a tunnel extension because I couldn't find a tunnel extension long enough still on the market. It's a little bit of an older machine. And then I got some little footwell things here. So what I'm working on right now is before I put these on, I want to make some little gripper pads for them. Problem is, I can't print good enough material for this project. So that's going to lead us into what we're doing today.
So the sled stuff is just a little taste. You'll see that when it's running later. But on Hellforce, Steve has made a couple of things.
Yeah, I think this is my favorite, new shift gate. Obviously, the stock shift gate didn't work with the Power Glide we got in this thing. So I made this, designed it up to work with the stock shifter and everything. Looks really good. Super happy with that. And the second thing on this project was an ECU enclosure. That was another thing that I just couldn't print myself because of where it's at. It needed to take more heat, and my printer's not capable of printing that filament. So I designed that thing and had to send it out and have somebody else print it, and that got expensive. So I don't want to do that anymore.
No good.
So what we're gonna do today is unbox something that'll take care of that problem, and then I can show you guys how I go about designing that stuff.
Oh boy. I've seen this box here for a couple weeks now, and I've just been dying to see what's inside.
Yeah, we're a secret part of the shop over here. So this started out as I just wanted to upgrade my printer at home, but I've also really wanted a printer for here. So I got a hold of Cheaty Tech, and it turns out they were super down to just send us a printer.
That's awesome.
Yeah, very excited about that. And I contacted them, like, this is the printer I picked out. Like, I spent weeks of research on this and like this one the most, so pumped about this. Special thing about this one, I mean, we'll get into it later, but it's also huge. It's very big for what it's capable of. It's very fast. We're just gonna unbox it now.
Okay. Just remember, this sign faces up.
Slight translation issue. We'll forgive
we're
them.
almost there.
Hopefully.
Oh, boy.
Oh, yeah.
Oh, we got some stuff.
There's some stuff.
What the heck is
A little
this?
toolkit, of course. This is a scraper to clean up the bed and get prints off. I got some rubber feet there. I'll explain this later. It's a little tool for whatever.
A screwdriver?
Yeah.
Some sort?
Instructions, a little more toolkit. All good stuff that we'll need later.
Looks like a phone cable.
Oh yeah, that's interesting. I don't know what that does yet.
For your
I'll be
landline?
honest.
Oh man. Still can't really see much.
No, I mean that's it, but I might just have to cut the sides of the box. It is the biggest of its kind in terms of enclosed fast printers. Oh yeah, look at that. We're getting there.
Max 3.
Starting to look like something.
You love X-Maxes, so I mean, it
I
just
do.
makes sense.
That's really why I wanted it.
Somehow help. Wow. That thing looks really cool.
That is super nice looking.
It's all metal on the sides, or at least it feels
This
like
is
it is.
plastic.
Oh, okay. Well, it
It's
looks nice.
Yeah, it's actually, so internally it's all steel, and then the enclosure is plastic.
Okay, yeah, just probably for insulation.
Yeah, let's see if I can get this thing on the table.
Oh, jeez. Steve, I'm sorry. I want to help.
There she is.
Yeah.
All right, pop the top. You can clear this out. More box of goodies.
What the heck?
We'll talk about that stuff later when we get this box opened up.
I don't know what any of that is. I just want to see inside this thing.
Just some foam. She's packaged it up pretty good.
Yeah,
Oh man, that is nice looking.
whatever that is. 330 by 330.
Yeah,
That
size
seems large.
size of the bed. It's pretty good size. Like typically, like 250 mark is like normal
Okay.
for fast printers.
All right, we got her plugged in. First startup. Ooh. I just want to say I know nothing at all about 3D printing, so I'm very excited to learn all about it.
It should come through with the startup instructions on this screen in case this is your first printer. It is made to make it super easy. And I did forget to mention, GDTech did give us an affiliate link. So if you are interested in this stuff, you can check out the link in the description to this exact printer or their store in general. And that helps support the channel big time.
Oh, some stuff lit up.
Oh yeah, dang, that's pretty looking.
Yeah, I'm assuming that they have all like a big range of machines. Like,
Yeah.
all different budgets and
Yeah,
capabilities
and they have 3 different sizes of this general new model range. So
okay.
yeah, see, then it's going through, remove all the zip ties, which I did mostly. We'll do that. There's 4 screws to hold the bed down just for shipping in the
Mhm.
corners there.
So the bed moves.
Yeah, the bed moves up and down, and then this print head is the X and Y.
Okay. Well, that's pretty
And that's
foolproof.
that's one of the things that helps it go fast, is that type of motion. It is. Let's get this plastic wrap off this thing quick. Yeah, and that's magnetic.
Okay.
Hold down, very nice. Lifting up so I can get the zip ties out, and there's some foam underneath there. Alright, set at 60, that's basic.
So is that a normal thing? Like, does your other printer heat the bed?
Yeah, pretty much all modern ones do to get the print to actually stick to the bed, or else
Okay.
it's really hard. It'll get halfway through the print and the print will peel off, and then you just get spaghetti all over the room.
Gotcha.
So this is really the only one manual thing you have to do to set it up. You use this card and stick it under the nozzle, and that sets basically the home position. And this thing, I don't know if you'll be able to see it, But this has a sensor on the side, like some type of little induction sensor.
Okay.
That can sense the aluminum under the bed. But to set the home, you have to just stick it under here. And then you just wiggle it around until it gets some pressure on it. And you can adjust it on the screen. And there it's just barely touching. I think a little bit too much pressure. So I'm going to back down a tiny bit.
Oh, so it's like a feeler gauge.
Basically, yeah.
Okay.
Yeah, and right now there's just a tiny bit of pressure against the nozzle. So that's basically means the nozzle is this thickness away from the bed. And I think we're good enough there. So we can set that. And now it's going to go through and use that sensor to measure a bunch of different parts of the bed. Because no bed is actually perfectly level.
This is some serious stuff.
Uh-huh.
You know, it's a little hard to see that screen. Why don't you go ahead and peel that plastic off
Shoot. There it is.
of there? Oh, nice
yeah.
peel. Nice peel.
Alright, auto leveling completed. Oh, I didn't show the mesh there. This is the really cool part though. This is what allows it to go so fast. In a second, you're going to start hearing it make a humming noise. Now, anytime you move these print heads fast, all these rods and stuff flex and move a tiny amount. So this print head actually has an accelerometer in it. And right now it's going to shake it back and forth really fast to measure how much those rods are flexing. And then when it's printing, it will actually adjust the G-code to compensate for that amount.
Really?
Yeah, it's actually nutty.
Oh, I hear it. It's going through like different hertz. So while this is calibrating, got a few more points to make.
Yeah, so what this thing is special for is really intended is for like what's called engineering grade materials, stuff that's just hard to print on normal open printers and what I can't print.
Mm-hmm.
And a couple of things that make that possible is one, it's enclosed, but also it's got a heated enclosure, which is really rare in like reasonably priced machines. So that helps with stuff like what I'm using for the snowmobile is like ABS, which if you print on an open printer, if it gets any kind of draft or of air, it just warps and ruins the print immediately.
Oh, really?
With the heated enclosure, you don't have to worry about that. The print will just come down a temperature evenly. It's almost like annealing steel. You can think of it that way. And another thing that makes it special is this is where the filament goes in on the back of the printer. And this is a dry box. So another issue with those tougher filaments is they absorb water from the air really quickly. Like within an hour, they can be too wet to print.
Oh,
like
wow.
not wet on the outside, but internally they're wet. And when you run it through a hot nozzle, all that water boils off and it just screws up the print. Like a lot of times, like even during the print duration, filament will absorb enough water to ruin a print. So this thing, super helpful.
That's crazy.
That's pretty serious. Holy moly.
Yeah, I'll just run through how I design stuff and how I actually transfer it over the printer to get it to print. Alright, so this is the software I use to design stuff. This one's called Fusion 360. This is a free version. There's also one I like called Onshape that is browser based, so you don't even have to download anything. You just go to a website and log in and just start playing around with it. And this is our little foot grip here. Nothing too crazy, but you know, it's got some scalloped edges, some points to give you some traction. It's got the holes in it for rivets already. And basically on any type of the software, like I don't want to get too deep into it, but you start out with sketches. I'll make that invisible. And this was the base sketch, just the overall outline. And then I got the holes for the rivets in there. And then you extrude it to a depth to give it a three-dimensional shape. And then over here, I just did a second sketch. I just got a bunch of circles in there, and then I extrude cut those, and those cut all the scallops into the final part. So you can see they line up there. Super simple, just chamfer the edges, and that was basically it for this part. Nothing too crazy. Like anytime, if you haven't experienced this stuff before, it always looks overwhelming, but like half an hour on YouTube tutorials is enough to get you going. You just get in here, start messing around with it, you'll figure it out in no time. All right, before I close this out, I just wanted to explain real quick the file type that you use to print. If you go up here, instead of the normal save as, in some software you'll do an export because it says cloud-based saving, so you can export, and then you have to switch it over to an STL. And an STL is what the slicer we're about to use understands and can turn into a printable object. So here's one of the best websites ever. This is called printables.com. There's another one called Thingiverse, and this is where people go to just upload their files just for fun, basically. So if you don't want to jump into designing your own parts right away, you can come to this website and just search anything you're interested in. So I really like RC parts. I'll do a TRX4M, those little mini crawlers. And here's just a bunch of models that work for them crawlers. I mean, somebody made a set of skis, somebody made a trailer, some of these little pads to get unstuck. Here's a whole chassis for one. This is stuff you can just download and print immediately without having to design anything for free. Super cool. Alright, so this is the next piece of software. This is called a slicer. This is what takes models and builds something that's actually printable. So I just open up a file here. Got my little foot grip here. Import it. There it is. So then you got some settings over here. Like this is a quality setting. This is a layer height. So smaller layer heights will be more detailed, look prettier. I don't necessarily care about that, so I'm just going to do the fat layer height, make it as quick as possible. Got material over here. PLA is like the generic, just the easiest thing to print. The issue with it is it can't hold up to any temperature. Like leaving it in a hot car is even an issue. And for this specifically, it's kind of brittle, and I expect this to flex a little bit, which is why I wanted to switch over. I got ASA now, which is similar to ABS. It's just a little bit modified to be easier to print. Got a 0.4 nozzle, which is what comes standard in this. And then the last thing I'm going to change is infill. Normally 3D prints are mostly hollow. You got 15% infill. Because I'm literally going to be standing on these, I'm just going to make them 100%. And then we can slice it. And what it's doing is creating layers, because this printer creates an object one layer at a time. You can see right here. Okay, this one takes 6 hours. I'm going to mess around with that. Maybe I'll drop down the info a little bit, but it doesn't really matter. It's got 6 hours. Someone will say how much the total amount of filament used, which won't be that much. So down here it shows the total amount used, 191 grams. So a spool is 1 kilogram. So this is literally only going to be a couple bucks to print. And then we got to export G-code. Now G-code is just like movement directions for computers. So like this is what a CNC mill would operate on. Very simple stuff. Export it, G-code. I'm going to save that to the desktop. And then we can put that on a flash drive, put the flash drive into the printer and print. Or my preferred method is to send the printer over Wi-Fi. Yeah, getting ready to load the filament for the first time. That's the next step in the setup. This comes with a little bag of desiccant. Just stuff that in there. Get this lined up in the back. Lock her in place. And then this is the filament I chose for this one. I'm going with white.
Oh.
Here to spice it up a little bit, you know, compared to black.
And this is what kind did you say this was?
This is ASA, which is like really similar to ABS. So we can just straighten this end out a little bit. Get it in here. And then we have to feed it in, which can be a little bit of a pain.
Feed her through the little tube.
Yeah. And then this here is a run out sensor. So if you're in the middle of a print and run out, it'll detect that and you can put a new roll in and continue printing.
Now, how far do you have to feed that in?
This goes all the way up here to the print head.
Oh, okay.
So when it gets close, I'll feel it stop, and then I can push next on the screen.
Now, is this a material you could print with your printer at home that's just open?
No, I've tried quite a bit. So with it being open, it doesn't stay warm enough. And every time I've tried, it warps or cracks because it cools down too fast and it cools down unevenly, does some bad stuff. And since my printer's not set up for it, when I do enclose it using a cardboard box, it just gets too hot and the electronics shut down and it just ruins the print halfway through. It's a total waste of time.
Okay.
Oh yeah, there she is. Wow.
Oh.
I didn't think it was doing anything because it was so quiet. Well, you see it spit out a little black there. It's because they test them all. And now there's our white. Tutorial finished. Heck yeah.
Congrats.
So I got the printer all hooked up to Wi-Fi, and that gives us this screen here. This allows you full control over the printer remotely. Normally, you can come down here, add files to print. You can control the temperatures up here. So there's the nozzle, the bed, the chamber. I got the bed and the chamber warming up right now because it's kind of cold in here. And then we're going to go back just to the slicer again. And because this slicer is made to work with Cheaty printers, you can actually just come down here to this button, send to printer, upload and print, and then it'll just print. It'll come up to temperature, and when it's up at temperature, it'll just go.
Really?
Yeah, pretty rad. Don't even have to save the file anywhere else or transfer anything. Super easy.
Yeah, that is easy.
Come back to the device tab, and eventually, it'll just be going.
So if you want to just print some stuff that was already made, you just do that and it's ready to go.
Yeah, to print stuff already, like if you on printables or whatever, you can just come back here. You just save that file, download it from printables, save it, come here, add it to the print, do the stuff I showed up before, and then just do the same thing. Send to printer.
Yeah, that is awesome.
Super cool. Very easy.
There it is.
Oh,
We got
boy.
tip temp. We got fans.
Oh boy.
We got ourselves some extrusions.
There it's going. Just a little
Whoa.
test extrusion.
Sucker's fast.
Now it's going.
Oh yeah, that's the part.
Can you see it better from the top?
A little bit, yeah.
Oh, it's just tracing it out.
I'm just doing a quick outline.
Already highly satisfying.
Mm-hmm. Yeah, and this first layer is relatively slow to get it to stick to the bed better.
Okay.
So it'll move quite a bit faster later on.
This is the actual excitement. We're all just hovering over this thing.
I know what I'm doing the rest of the day.
Wow.
Okay.
So it's the next day.
Yeah, this thing finished printing a little bit after we left for work yesterday. Gotta peel it out. It looks pretty dang good so far. Oh my god.
Oh.
So that's something great that my printer doesn't do because it has a glass bed. It doesn't flex. This just came off super nicely.
That is awesome.
White is sometimes hard to tell over camera, but I mean, like the corners look great, the layers look great. I mean, that's
Don't snap it.
oh no, she's good. I mean, with like literally zero tuning by me, this is a fantastic looking print. Super jacked. So now I just gotta mirror it and do the other side. All right, so they're all done. Super happy with how they've turned out. I've been jumping on them already. They feel super strong and really grippy. Like,
Yeah, it looks.
that's nuts.
They look excellent, like a production part.
And I really enjoy that. Nobody else in the world has that exact thing. It makes me happy. And as you'll see in the outro, we've been printing all kinds of stuff on this printer. Like, I've fallen in love with it the last few days. It's highly recommended. If you haven't said it already, there's a link in the description if you want to check that thing out. I think we're going to wrap it up for this video. The next video with this sled, I think we're going to finish it and maybe even take it out for a rip if there's some snow.
Yes.
So, as always, thank you for watching. We'll see you next time.
That was great. Oh my gosh.